Here's the quadratic formula that you looked at in the previous lesson. And in this lesson, we're going to solve several equations using the quadratic formula. In each equation, we'll need to identify A, B, and C and plug those values into the quadratic formula. Before we do our first problem, we're just going to jot the formula down up at the top. We're also going to jot the form ax squared plus bx plus c equals 0 over on the top left, and the formula itself on the top right. And here's our first equation. You may recognize that this one could be done very quickly using factoring, but we want to use one that can be factored to show that it can also be done using the quadratic formula. And we identify that A is 1, B is 7, C is 12. Then we plug those three values into the formula as shown. Then we do our arithmetic. Order of operations says we do 7 squared to get 49, 4 times 1 times 12 to get 48, and 2 times 1 to get 2. Then our next step is 49 minus 48. That can be done quickly. Our next step is the square root of 1, which is 1. And then we divide this one into two separate equations, and we simplify them both. And our two values are -3 or -4. And just as you could have done it with factoring, now you can see that it can be done with the quadratic formula. But here's an equation that can't be factored. So we have to use the quadratic formula. We identify that A is 1, B is 9, and C is 12. Substitute those values in. Perform some order of operations to get 9 squared is 81. Once again, 4 times 1 times 12 is 48, and 2 times 1 is 2. In this one, it's 81 minus 48 is 33. And again, we'll talk a little more about simplest radical form in a future lesson, but for now I will just tell you that this solution is in simplest radical form, and it's considered to be the exact answer. But if you'd like to use your calculator to round it to the nearest hundredth, there they are. The two solutions to the nearest hundredth are -1.63 and -7.37. Here's yet another problem. C is negative. A is 1, B is 15, and C is -18. And when we plug them in, we get this. And when we do the order of operations, we get 15 squared is 225. But notice where it says plus 72. We got that because 4 times 1 times -18 is -72. But when you subtract -72, that's the same as adding 72. So that's what we wrote. And then 225 plus 72 is 297. And that's all over 2. And then this is the part that you'll want to work on in a future lesson. But for now, you're looking at 297. And you're asking yourself, is there a perfect square that goes into 297? And there is. It's 9. So since 9 times 33 is 297, we can write them as shown. And then we can take the square root of 9, which is 3, and bring that out of the radical symbol. And now we have it in simplest radical form. And again, if you'd like to round that to the nearest hundredth, get out your calculator. There are the values, 1.12 and -16.12. We need more room on this one, so I've not written the quadratic formula. It's time to memorize it. We have 3x squared minus 10x plus 6 is equal to 0, and you'll notice that A is a number that's not 1. It's 3. B is -10, and C is 6. So we plug in, and notice where it said the opposite of B in the formula, now it says the opposite of -10. So we have a double negative there. Notice we also have -10 to the second. So we put the negative in parentheses so that we don't mess up our order of operations. Now we do the arithmetic, and of course the opposite of -10 is 10. -10 squared is 100, and 4 times 3 times 6 is 72. And our denominator is 2 times 3, which is 6. 100 minus 72 is 28. And now we're looking for a perfect square that goes into 28. And that's 4, because 4 times 7 is 28. Well, the square root of 4 is 2, so we remove the 2 from the radical, and we get 10 plus or minus 2 root 7 over 6. And now our simplest radical form gets even more interesting. Just as we could factor 10 plus 2a, we can factor 10 plus or minus 2 root 7, because the 10 and the 2 are divisible by 2. So we factor out the 2. And now that we factored out the 2, you'll notice we have a 2 in the numerator and a 6 in the denominator, and they're both divisible by 2. So we mark out the way you've been marking out fractions since you were in 3rd or 4th grade. And there it is. So our simplest radical form is shown at the very bottom right. And now we'll go to another frame because we need a little more room, because if you'd like to round it to the nearest hundredth, pull out your calculator, type 5 plus square root of 7 and divide that by 3, and then type 5 minus the square root of 7 and divide that by 3, and you'll get the two solutions shown at the bottom, and they're both rounded to the nearest hundredth. Here's one more equation. We have A is 12, B is 28, C is 15, and we plug them in as shown. And then we do 28 squared to get 784, and 4 times 12 times 15 to get 720. We subtract 784 minus 720 to get 64. And by the way, we've also done 2 times 12 in our denominator to get 24. Often we're used to A being 1, and we get in the habit of making the denominator 2 times 1 or 2 every time. But pay attention, whenever A is not 1, make sure you do 2 times A in the denominator. Now in this case, the square root of 64 is 8. So now we have no radical, and we're going to be able to split this up and get 2 rational answers. And on the first one on the left, our final answer in lowest terms is negative 5/6. And in the one on the right, we get negative 3/2. They're exact solutions. We don't need to round off in this one. And in fact, because the square root of 64 came out even to be 8, that's something that tells us that we could have solved this using factoring. But the factoring might take so long in this one that it might actually be faster to do it the way we've just done it. But just so you can see, this factors to be this. But if we remember, we often use splitting the middle term and factoring by grouping, and it took quite a while to get to this. But if you did all that work, this is what you'd get. And you'd break it into these 2 equations, and then you'd add negative 5 to both sides on one, and then divide by 6 to get negative 5/6, add negative 3 to both sides on the other, and divide by 2 to get negative 3/2. You get the same solutions whether you factor or whether you use the quadratic formula, but in this case, the factoring might take so long that I believe it might be the quickest to use the quadratic formula. Once again, the quadratic formula states that in an equation ax squared plus bx plus c is equal to 0, you can solve for x by making your numerator the opposite of b plus or minus the quantity b squared minus 4ac, and that numerator is then divided by 2a. And in order to use the quadratic formula, you determine the values of a, b, and c, and then substitute them into the formula.